Hello my lovelies, it's Susanne, and today I want to show you how to solve this problem that was part of an advertising campaign of a fast food chain. I really looked it up, and in 2020 they posted this problem here on Twitter. You get a free burger with your order if you figure out the promo code. And this beautiful thing here is going to be our promo code. So let's take it and let's see what we can do with it. Okay, there is a lot of stuff going on here. I mean, it starts with this minus. Okay, we can handle that so far. But then we have this symbol here, and this is a sigma. We're going to take a look at this sigma in detail later on, but for now, we just acknowledge that it is there and that the index of our sigma is an I. An I goes from 1 to 461. And this I is also in here somewhere. We can only find it here. For now, we just acknowledge again that this I inside here belongs to this sigma here. Okay, so inside we have this -1 raised to the power of I. We're going to take a look at it later. And all of this is multiplied by this expression here. And in here we have factorial. 5 factorial and 4 factorial, and maybe we start here so that we start somewhere, and we start with the 5 factorial and take a look at this first. Factorial is a short version for you start at this number, so you start at the 5 and then you multiply by the next smaller number, so by 4, by the next smaller number, and down to 1. This is 5 factorial. And the same with 4 factorial. If we write it down as well, this time you start at the 4. So we have 4 times 3 times 2 times 1. Let's start here then, and let's write everything else down as it is, so we don't change it for now. Our I starts at 1 and goes up to 461. Inside we have our -1 that is raised to the power of I, and all of this is multiplied by, and here we're going to change these things now. Instead of 5 factorial, we're going to write it down what it actually is, this product here. And then don't forget to multiply all of this by 5, because that was what was there from the beginning. And down here we have 4 factorial, so we have this product here. And then all of this is raised to the power of 1 over 2. And I want to write this in a different way. So if you have something like x to the power of 1 over 2, you can always write this as the square root of x. So instead of the square root, you can always write it as raised to the power of 1 over 2. Depending on what you prefer to work with, you can either use the square root or this power here. I prefer the square root now because then we really know what we're working with here. So instead of the raised to the power of 1 over 2, I'm going to write a big square root in here and then close all of this. Okay, now we have a fraction. There is a product everywhere, so we can cancel things out, the 4 and the 4 and the 3 and the 3 and all of this, so that in the end, only 5 times 5 is left. So what do we have there then? We have our sigma, I equals 1 to 461 still. Then inside, still our -1 raised to the power of I. But now we have the square root of 5 times 5, so the square root of 25. But we can calculate this. The square root of 25 is just 5. It's important, it's not negative 5 or 5, it's just 5. So the square root of a number is always just the positive result. So this is how our expression looks like now. And before we take a look at this sigma, we can still make this expression here a little bit easier because we have this times 5 in here that doesn't have an I in it. We can take this times 5 and take it in front of our sigma. So we have the negative 5 then in front of our sigma, then this beautiful symbol that starts at I equals 1, goes up to 461, and inside we only have the negative 1 raised to the power of I now because we took this outside of our sigma here. Okay, but now we're going to take a look at sigma. Sigma is just a short version of a sum. So this thing, what we see here, is actually a sum. So something plus something plus something plus something and so on. And our sum starts at I equals 1. So the first thing is I equals 1. And if we set I equal to 1, we have negative 1 raised to the power of 1 here. So negative 1 raised to the power of 1. Then we increase our I by 1. So we have I equals 2. So we replace I by 2 so that we have negative 1 raised to the power of 2 here. Then we increase I again, and we get I equals 3. I think you get how it works, so that our next thing here is negative 1 raised to the power of 3, and so on, up to I equals 461. And so that we have as our last thing in here, negative 1 raised to the power of 461. Let's pray that there is a pattern in here, because we have to calculate this thing. We need a number in the end for our burger. So here, let's start here. We have negative 1 raised to the power of 1, which equals negative 1. Then the next element, we have negative 1 raised to the power of 2, so an even number. Then the result is going to be positive. So we have positive 1, because negative 1 times negative 1 equals positive 1. Next element, we have an odd exponent. Negative 1 raised to an odd exponent gives us negative 1 again. And if we have the next even exponent, we're going to get a positive 1 again. And so on until, well, the last element, we have an odd exponent. So this result is going to be negative again. So we don't have a plus 1, we have a negative 1. Okay, so if we take a look at it, we have negative 1 plus 1, which cancels out, negative 1 plus 1, which cancels out. So every time we have an odd and then an even exponent, these two cancel out. So odd, even, odd, even, odd, even always cancels out. So the last even exponent is the 460. This exponent cancels out the negative 1 before it. So the only thing that is left that doesn't have a partner to neutralize, so to say, is the last element. So we have 0 plus 0 plus 0 plus 0, and in the end we have the negative 1 as a result of this whole sum. So this equals negative 1. So in total, we have negative 5 times negative 1, which just equals 5. and this is our promo code. So I hope we all got our burger. If you enjoyed the video, please give it a thumbs up. I wish you a wonderful day, and I hope to see you in one of my next videos. Take care.